we go for the next part of the construction in the chapter geometry construction. We are finished with the triangle. Now we go to the topic of circle, and when it comes to circle, the construction is mainly of construction of tangent to a circle. Now construction of tangent to a circle, and in this you have two types. One is to construct a tangent at a point on the circle, and the second type is to construct a tangent to a circle from a point outside the circle. So if it is outside the circle, there is only one way of doing, but whenever we have to construct a tangent when the point is on the circle, there are two methods. One is without using center and the other one is with using center. So we first learn how to do it with using center, the construction of tangent to a circle, and after that we will see without using center. Okay, so let us start with exercise 4.2. First sum. Construct a tangent to a circle with center P and radius 3.2 centimeter at any point M on it. So see children, whenever we say circle, circle is identified by its center and the radius. So here the center is named as point P and the radius is 3.2 centimeter, and there is a point M on the circle for which we have to draw a tangent. Now let us recall the theory behind it, what we have studied in circle chapter. What is the speciality of the line tangent to a circle? Yes, tangent is perpendicular to the radius. So taking that point in mind, that is how we are going to do the construction. So let us start. Keep your pencil, compass ready with your scale always as needed. So here we start. We have to draw first a circle of 3.2 centimeter, and I am sure everyone would love doing this. So here we have the center P and we draw the circle. Yes. So here I have a circle with center P. So as I take this, the center is important because I have to draw the radius. So I have my center P here and this is my radius PM. At point M we have to draw tangent. So to draw tangent at M, it is same as we have to draw perpendicular line at point M. How do we draw perpendicular line? So for that we just extend this, okay, and with the help of the compass, how do we draw perpendicular? At point M, we draw arcs facing each other. At point M, we draw arcs facing each other. Okay, and see, when we draw this arc, we take suitable distance. Now if you need, you can change the distance, and we take our distance from this arc what we have already drawn. We will draw an arc on this side and this side, keeping the same distance, and from the arc what we have already cut before, cut the arc what we have already drawn. Now join the common point, and while drawing you will find it will pass through point M. So this is how we draw the tangent at point M. So it is always easier to draw a perpendicular at a point on the line. Yes children, So using this method, this is not a new method for you at all. So we name the line L, and this line L is the tangent at point M for the circle with center P. If you look at the second sum, it is also very similar. It just says draw a circle of radius 2.7 centimeter. I'll just show you the rough figure. 2.7 centimeter. They have not told us to name the center nor the point. Draw a tangent to the circle at any point. So let us name this as O and let us name this point as R. So at point R you have to draw the tangent. So the methodology is the same, right? The methods what you have to follow for the construction is the same. So it is a similar sum. So I would like you all to practice it on your own. Now we go next to sum number 4. Yes, sum number 3 is different because the question says without using center. We'll come to that method later. We go for the sum number 4. What does it say? Draw a circle of radius 3.3 centimeter. Draw a chord PQ of length 6.6 centimeter. Yes, children, can you make out what kind of chord would be this? If radius is 3.3 and the chord is 6.6, yes, any guess? Very correct, it would be the diameter, the longest or the largest chord of the circle. Draw tangents to the circle at points P and Q. Write your observation about the tangent. So let us take 3.3 in our compass. Okay, let us draw a rough figure for our understanding. Here we have a circle. 3.3 is the radius and the chord is PQ 6.6. Right? Double of 3.3 is 6.6. So therefore that gives us the hint that PQ is the largest chord of the circle which passes through the center. Now at point P and Q you have to draw the tangents. Possible? Simple? Yes or no? So let us start. Take your compass. Take 3.3 in your compass. Draw the circle. So let us draw the circle. I hope you are doing along with me. So here we have the circle of 3.3. Let us mark the point O. So this is radius 3.3. So how do we draw the chord? 6.6. So take a compass and mark 6.6 and we can just draw it by joining the any one of the diameter passing through the center. Okay, so you will find it is 6.6. Right? So this is my point P, this is my point Q. Now at point P and Q, how do we draw the tangents? Very simple. Before naming it, we will first extend it outside and we will draw the perpendicular. Same way on this side also we will draw the perpendicular. So drawing any one of the diameter will help us to do the sum further. Is that very clear? So to draw the tangent at point P, take a suitable distance, cut two arcs facing each other. Now from here take a suitable distance out and draw an arc. Keeping the same distance, cut the arc drawn. Same is what we are going to do at point Q also. Arcs facing each other. take a suitable distance, take at this point, draw an arc. With this, cut the arc what you have drawn. See here children, I have only taken arcs on one side because I will have a common point here, I will have a common point P here, P and Q, right? So I will join the two common points to make the line much more specific, touching at point P. So I draw my tangent passing through point P. Here is the tangent passing through point Q. So we can name this as line L and line M are the tangents passing through points P and Q respectively. So that is, write your observation about the tangents. What is your observation about the tangents? They are parallel to each other. Agreed? Why are they parallel? Because both these angles are 90 degrees. So therefore the two tangents are parallel to each other. Agreed or not? Because the interior angles are supplementary. Okay. Going further, we go for the next sum. Sum number 5. Okay. So let us get starting. Yes. Now in the fifth sum, again you have a chord to be drawn. Okay, again you have a chord to be drawn, and but here the chord is just not equal to the diameter. Okay, so let us draw the figure. I hope you are ready, girls. So the circle is having radius 3.4 centimeter. And then you have a chord MN which is 5.7 centimeter. So we have to draw 5.7. Taking in the compass, we'll cut at these 2 points, and that is how we will get 5.7 centimeter MN. After getting this, what they are asking us, construct tangents at point M and N to the circle. So from the center O, join OM. So OM is the radius of the circle. So for that radius OM, whichever is perpendicular becomes the tangent. So at this point, if I draw perpendicular, that will be a tangent for the circle at point M. Same way at point N2. If I draw a perpendicular, that is, it is perpendicular to ON because ON is the radius. It is perpendicular to OM because OM is the radius. So this is your line L and this is line M, which is the tangents to the circle. So let us start. Here we have a circle with radius 3.4. So let us draw the circle. So here I complete the circle. Yes, there is little error. So I complete the circle. And to this circle I have to take a chord 5.7 centimeter. For that, again you take your compass. With the help of the scale, take 5.7 in this compass. And keep at one point on the circle, cut at the other end, same distance, do the same thing on the other end. So that is where you get your chord MN, join this, that is chord MN. MN, and here we have the point O. So what do we do is we join OM one at a time. So we first finish at point M. Okay. At point M we draw perpendicular. How do we draw perpendicular? We take a short distance here, a short suitable length in the compass, mark both the end, arcs are facing each other. After the arcs are facing each other, what we do? We extend the length and we take a distance from here so that we can draw an arc outside the circle. Same way from this point with the same distance. Cut the arc what is drawn, and common point, that is point M and the common point of the arc is what we will join. That gives us the tangent at M. Let us name it as line L. Similarly, at point N also we do the needful. How do we do it? We draw the radius ON first. Yeah, without drawing the radius we cannot draw the tangent, because here we are doing with the help of the center, and that is why we have to draw the radius to whenever we are using the center. So at point N, take a suitable length in the compass, mark the arcs facing each other. You can say forming C facing each other. You are drawing perpendicular to ON. So see that you draw the arcs on ON. After that, take a suitable length in this and draw arc outside the circle from these two points which we have marked, and from there you have the common point. This is the common point what we have. To the point N we draw a line, and this is line M which is perpendicular to ON. This is line L which is perpendicular to OM. Be particular to show where it is perpendicular. It is perpendicular to the radius. It is not perpendicular to the chord MN. Okay children, pay attention to that. It is tangent is always perpendicular to the radius. So this is what is the construction here. Now after this we go for the next one, that is the sixth sum now. Okay, let us read the question. Draw a circle with center P and radius 3.4. Take a point Q at a distance 5.5 centimeter from the center. Construct tangents to the circle from point Q. So you have a circle with a radius 3.4. Then you have a point Q which is at a distance of 5.5 centimeter from the center. So from the center it is at a distance of 5.5. That is point Q. And from this point Q you have to draw tangents to the circle. How will the tangents come? So for that, first and foremost, we have to remember, again we are going to use the same property, that is perpendicular, that a line perpendicular to the radius is the tangent, okay, or tangent is perpendicular to the radius of the circle. So keeping that in mind, first and foremost we are interested in OQ, okay. Now for this OQ what we do is we draw the perpendicular bisector. How do we draw perpendicular bisector? Yes, we had done in the basic construction how to draw perpendicular bisector of a segment. So here your segment is OQ, for which you will draw the perpendicular bisector. taking more than half. Yes. So taking more than half will let you get the perpendicular bisector. After you get the perpendicular bisector, taking this as the center and this distance, if I mark this point as P, taking PQ as the distance, you will draw a circle or you will draw an arc which will cut these 2 points, and that will give you 2 tangent segments which will be congruent. Yes, from Q the tangent segments are drawn, so let it be at point R and S. So this QR will be equal to QS. This is how the construction will go. So let us start. So draw the circle with 3.4 centimeter. Yes, keeping in mind this distance what we want. See children, we can do it this side or we can do that side. It is either way one and the same. So it is up to you however you feel comfortable. So here I draw the circle. .4 centimeter. So this is the center O and this is 3.4. Now from point O we have to take 5.5. So from center it is 5.5. So already 3.4 is covered here. So how much more to get 5.5? Yes. Tell me first. Already 3.4 is covered here. So we have to draw 2.1. So instead of doing that, we will keep at center O. 3.4 is covered and we draw further 2.1 and we join the segment to point Q. After getting point Q, now we will draw the perpendicular bisector. Now this whole thing is 5.5. What is half of 5.5? Roughly, at least 5.4 if I take roughly, the half of 5.4 will be 2.7. So it will come somewhere inside the circle. It doesn't matter because we are not drawing a tangent now. We are drawing a perpendicular bisector of segment OQ. It doesn't matter. So we take more than half. We draw above the segment and below the segment. This time we are drawing it above as well as below the segment. And that is how we are going to get common points. After getting the common points, we join them. Yes children, it will come inside the circle. You need not worry. That itself tells you that you are perfectly going correct with the construction. And after drawing the perpendicular bisector of OQ, keep at point, let me name this point as P. Keep at point P, take distance OP or take distance PQ. It would be one and the same. Right? Now, you will draw arcs cutting the circle. So when I draw arcs cutting the circle, it goes like this as well as like this. After I cut the circle, see children, you can draw a circle touching the whole way. Okay, but it looks, the construction becomes a little more messier. So I have just cut it and you get the common point. So from point Q to this common point, what we have, draw a line. And when you draw that line, you will find it is exactly a tangent touching at only one point. So you have QR and QS as the tangents drawn from point Q to the circle. Okay, now if you see again, you have again the same type of sum, that is the seventh one, and that is what you can see, it is similar. So I want you to try that on your own.